Some operations just can't predict how long they'll take, but that doesn't mean users should be left in the dark. We'll implement a directory scanner that sends continuous progress updates, even when we don't know the total work ahead, using FastMCP's indeterminate progress reporting to keep clients informed every step of the way.
At MCP, tool. Async def scan directory, SDRCTX, context, dict. Scan directory with indeterminate progress. Files found equals 0. Hash simulate directory scanning. For I in range 10, hash unknown number of files. Files found plus equals 1. Hash report progress without total for indeterminate operations. Await CTX, report progress equals files found. Await Asyncio sleep 0, 2. Return files found directory.
This demonstrates the indeterminate progress reporting pattern for operations where the total work is unknown or variable. Unlike percentage-based progress, this approach communicates incremental completion without a defined endpoint, using absolute values that clients can interpret as activity indicators rather than precise measurements. The distinctive aspect is its ability to maintain user engagement during unbounded operations without requiring upfront knowledge of the workload. The pattern works by decoupling progress signaling from completion metrics, focusing on the concept of liveness rather than completion. The tool emits progress events at logical intervals, allowing clients to display activity indicators like spinners or growing progress bars, while the server maintains a simple, stateful counter. This separation of concerns keeps the core logic clean while providing essential feedback to users or monitoring systems. This approach solves the common problem of unquantifiable operations where traditional progress bars fail. It's particularly valuable for file system scans, network discovery, or any I/O-bound task with unpredictable duration. The trade-off is that clients receive activity confirmation rather than precise timing estimates, which is often sufficient for maintaining user trust during long-running processes. Let's break it down.
At MCP, tool. Async def scan directory, SDRCTX, context, dict. Scan directory with indeterminate progress. Files found equals 0.
This defines an AA callable tool using the @MCP tool decorator. The files found counter tracks progress during directory scanning, enabling indeterminate progress reporting through the context parameter.
Hash simulate directory scanning. For I in range 10, hash unknown number of files. Files found plus equals 1.
This simulates an indeterminate directory scan by incrementing the file count in a loop. The fixed range of 10 mimics unknown progress, demonstrating how to report incremental updates when the total isn't known upfront. This pattern handles operations where the final count isn't predictable, like real-world directory traversal.
Hash report progress without total for indeterminate operations. Await CTX, report progress equals files found.
This reports progress for indeterminate operations where the total count is unknown. The context parameter handles progress updates, enabling UI feedback during long-running tasks without requiring a known endpoint.
Await Asyncio sleep 0, 2.
This artificial delay simulates real-world I/O latency during directory scanning. It prevents the loop from executing too quickly, making progress reporting visible and realistic. In production, this would be replaced by actual file system operations that naturally introduce delays.
Return files found directory.
This returns a structured result dictionary, the standard output format for FastMCP tools. The keys match the tool's documented schema, ensuring AI models receive predictable, typed responses that include both the operation results and context. Indeterminate progress pattern. FastMCP's context object handles unknown duration operations by reporting incremental progress without totals, keeping clients engaged during unpredictable workflows. The progress updates must be sequential integers, never percentages or floats, even when the endpoint is unknown. This approach transforms uncertainty into a measurable rhythm that both client and server understand.
The progress bar that never knows its end still reaches completion.